So let's go to reliability. Reliability is the degree to which measures are free from random error. Okay, so focusing first on reducing that randomness. When we look at reliability, we're going to have to assess reliability. When we look at reliability, we're looking at, do we get consistent data? Okay. One thing we can do is do test-retest. And test-retest looks at, do we get the same results? So the same, let's call this the same measuring instrument produces the same results when used a second time under similar conditions. Okay, so for example, let's suppose that you stand on a scale. You stand on a scale and it says you weigh 130 pounds. If 5 minutes later you stand on the same scale, so same measuring instrument, does it still say that you weigh 130 pounds? So we want the same measuring instrument producing the same results when used a second time under the same conditions. So not enough time has passed for you to gain weight or lose weight. It's the same environment, the same scale, the same you. You should be weighing the same. That would be a reliable measurement tool. So we would say the scale is reliable. It doesn't change when we retest it. We're getting consistent data. So we use test-retest for particularly the ratio data where we have those measurements that we're taking. So if we measure someone's height, someone's weight, it should be the same when we measure you a couple minutes later. Okay. Now it's not a measurement right when there is enough time for those types of things to change. So we want to make sure that under the same conditions, we would get the same data. So is it reliable? Do we have consistent data? Okay. Now, the challenge, of course, with a lot of our measurements and tools is that test-retest can't always be used, right? It's easy enough with a scale, but when we look at things like surveys, it's difficult to do test-retest because if we ask you the same question a couple minutes later, you have already seen the question, so that's going to influence you. That first measurement might alter your response to the second one. It might be difficult to locate people and retest participants, or depending on how much time has gone by, environmental or personal factors change, causing the changes in responses. So this test-retest for measuring the reliability of our research tool is going to be kind of limited to those more experimental design where we look at height and weight and other measurements, other ratio scales. It's hard to use that for, say, a survey that's measuring people's opinions because they can quickly change. We have a measurement for reliability that's called equivalent form. So this is one thing that we could do with surveys is we can use... So we use very similar forms to create closely correlated results. So here, what we could do is we could measure the reliability of our study by administering another survey 2 weeks apart that asks similar types of questions. So not exactly the same question, but similar questions to see if we get the same interpretation. So we could do this, for example, with like a math test. Is it a good math test that we gave you? Well, if we create 2 math tests that are similar in how hard they are and you get the same grade in both, right, then we have a good test, a reliable test. This would be like when instructors create version A, B, and C for an exam. You need them to be reliable. And we use equivalent form reliability. They should be the same level of hardness. So an A student gets an A in all of them, a B student gets a B in all of them. So if you were to look at these two math tests here, are these two math tests reliable? They would have to be that you would get the same score in both. Well, notice that these two tests, the version B is quite harder. So these are not equivalent. We need to, if we're going to use two tests to measure the reliability of a test, they need to be similar. Okay. How could we make them more equivalent? Well, we could put some of the hard questions from B onto A so that they both had some easy questions and they both had some hard questions. Now, it can be challenging to create two totally equivalent forms. It can be very time consuming to create equivalent forms. It can be very expensive to do that. But if you are, for example, the one administering SATs or AP exams or diplomas in Alberta, or you're an instructor who's creating multiple versions of your test, you need to have it be reliable. You need for the A student to get an A in all of them, the B student to get a B in all of them, for them to be truly reliable. That is, they give you consistent data. And then we could use them and have people do different ones in order to truly assess their grade. So the idea with equivalent form reliability is to see if your form, your survey, your test really does give you the same results, does it give you use very similar forms to create closely correlated results. And so we need them to be basically measuring the same thing. So in terms of reliability, we have test-retest. Do we get the same results for the same instrument when we measure twice? Do we have another form or survey that asks similar questions that we can use to measure whether or not we're getting the same opinions from people? We ask them similar questions 2 weeks apart. Are they giving us the same opinions? Okay. The third reliability measure here is internal consistency reliability. Internal consistency reliability is where we use here we're using very similar forms on different that's not right. Use very similar forms on different participants. To create correlated results. See, that's not the correct definition because we're not using similar forms. What we're doing is taking subsamples of forms. So I don't know why my notes say that. Use portions. So I'm going to get rid of that. The difference between, if we look at the equivalent form, that's two different forms on the same person. So let's just go back. So the idea here, let's just be very clear. Equivalent form, that is two forms on the same person. Equivalent form, two forms, same person. Okay, as opposed to that internal consistency one where we have different people. Same form. Okay, so this one was two different forms. Technical difficulties here. Two forms, same person is equivalent form reliability. Internal consistency, same form, different people. So how does this work? It works by basically dividing questions, dividing your form into pieces, and you are giving half to each group. So an example of this is Cooter-Richardson 20. Cooter-Richardson 20 is used when we are looking at test questions. So here's the output from a exam. Okay, so here we've graded 37 people. There were 20 questions on the test. And what you see here is a Cooter-Richardson of 0.68. Okay, so what this does is it takes the test and it takes a subset of the questions and it looks at, if we just graded 10 out of these 20 questions, so let's take the first 10, would each student get the same grade as grading all 20? What if we took every other question? So we just took the odd questions. Would they get the same grade? What if we just took the even questions? Would they get the same grade? That's essentially what the Cooter-Richardson 20 test does. So it's taking a sample of questions to see if the students would get the same grade. Does the top student still get the top grade? Does the lowest student still get the lower grade? So we have one test here, but we're looking at different students to see if we had pulled just some of the questions from the test, would those different students still get different grades? Would they still be getting the same grade they got before? So it's a split half technique is what it's called here. We divide the questions in half. We give the half to these different groups. With the Cooter-Richardson test, if we have a KR20, that's about 0.9. What that tells you is that your questions are of equivalent hardness, right? So there is homogeneity to your questions. That is, you don't have a bunch of super easy questions and a bunch of super hard questions. If you have a KR20 that is quite low, then that means that you have a handful of questions that are super easy and questions that are super hard. Because when it randomly samples from the test, if your weak students are getting really high grades based on one random draw of questions, because they're the easy questions, and then those students later are doing really poorly if it randomly samples from the hard questions, there is not internal consistency. If your smart kids get high scores, no matter which subset of questions we look at, and your weak students get low scores, no matter which questions we pull from the greater group, then you have internal consistency. Strong students do well, weak students don't do well, no matter which questions we consider. So that is internal consistency, a measure of reliability. Do we get consistent data? That is, are the grades the same for the students, regardless of which questions we happen to ask them? For your survey, it would be, do you get the same in terms of opinions, regardless of whether the questions are worded this way or worded that way? Are we getting consistent information? So reliability, internal consistent reliability. We have the same form, but different, looking at different people. Equivalent form reliability, we have different forms than the same people. And then test-retest, we take the same measurement tool and the same people and see if we get the same. So you're seeing here, we're looking at, is the data consistent, whether it is the same person and the same tool, whether it is different tools but the same people, whether it is the same tool but different people. That's what it looks, that's how we measure reliability. We want to compare this to validity. So validity we'll talk about in our next video.